Warmly welcome to the 20th anniversary Millennium Technology Prize award ceremony. My name is Amel Gailey, and I'm honored to be your host this exciting evening. We have an incredible evening ahead of us. We're going to hear wonderful performances and inspiring speeches. Your Excellencies, honored guests, may I have your attention, please? Your Excellencies, honored guests, it's time to officially begin the award ceremony. A warm welcome to the 20th anniversary Millennium Technology Prize award ceremony. For 20 years, the prize has highlighted innovations for a better life, a celebration of science, technology, sustainability, and well-being. The prize is awarded every second year. My name is Amel Gailey, and it is my honor to be your host this evening. In the next 45 minutes, we will celebrate innovations for a better life. We'll hear wonderful speeches and beautiful music. We just heard from Meta 3, and what a beautiful beginning that was to our evening. Now, let's welcome Chair of Technology Academy Finland, Professor Minna Palmroth, to the stage. Let's give her a huge welcome.
Dear Professor Baliga, dear friends of the Millennium Technology Prize, we are celebrating here the 20th anniversary of the Millennium Technology Prize. The prize was established by Prime Minister Lipponen, supported by our government, academia, and technology industries. The patron of the prize is our president. Already from the start, Millennium Technology Prize was seen as Finland's contribution for a better life. It celebrates the technological innovations which will make the world a better place to live. We can solve the challenges we have in today's world with developing technologies. The Millennium Technology Prize has risen among the 4 most important and prestigious prizes in the world, the 3 others being the Nobel Prize, the Fields Medal, and the Turing Prize. For example, within this year, we have been highlighted in the Financial Times, the New York Times, the BBC, and the Guardian. It's amazing that we have achieved this in just 20 years. I want to make 3 points illustrating the value of the Millennium Technology Prize. First, the value of the prize is not the 1 million euro we give to the award winner. It is the network of the prize winners. These people have changed the world verifiably. They come to Finland, they talk to us, they reflect, become our friends. Secondly, the prize is not only a beacon that sets the bar for national innovation, it also gives us soft power to show where we the happiest and one of the most educated nations in the world, want to get the world to go so that it stays sustainable. It also gives us highlights in the world by celebrating the education, science, and facts. Thirdly, and most importantly, there are many kids and young people today who are frustrated and scared about the future habitability of our planet. The prize winners are brilliant examples of people who have turned their intellectual capacity into practical action. It has been calculated that one kid that is marginalized costs 1 million euros. So if even one kid follows the example of the prize winners, it is worth it. And more, if they become innovators when they are in charge, we have turned their frustration into action and profit. I'd also like to say something about the innovation itself, the IGBT. Let us imagine two axes, horizontally whether there is talk and vertically whether there is impact. we get 4 fields: no talk, no impact, no talk, no impact, lots of talk, no impact, no talk, lots of impact, and then lots of talk and lots of impact. I get the feeling that many people stay in the corner where there is lots of talk about things which are of no consequence. Look at the social media, for example. Then there are prizes like the IGBT, which are, in fact, literally changing every life on Earth. But people don't talk about them because they are too difficult to understand or because they don't involve the celebrities or the royalty. It is absolutely fitting that we Finns, who are proud of not talking but doing, give the prize to Professor Baliga. The prize decision reflects the identity of our nation. Are we here to talk or to innovate? I truly hope that the Millennium Technology Prize 2024 will shine the world's awareness to IGBT where it belongs. I also hope it inspires the young to choose natural sciences and technology. I also hope that it inspires the adults to use their remaining time to read about difficult technologies and not about the celebrities. This is the world I want to work for, and I hope all of you join in this mission. Thank you so much.
Thank you so much, Professor Palmroth. Our next speaker is Päivi Törmä, Chair of the International Selection Committee of the Millennium Technology Prize. In her speech, we will hear about the criteria leading to the selection of the winner. So warmly welcome, Professor Törmä.
Your Excellencies, honored guests. As the head of the International Selection Committee, it was a great pleasure for me to learn to know about the insulated gate bipolar transistor, IGBT. I didn't know about it before. And when the prize became public, I asked my family whether they know. My younger son didn't, and my husband, who is also a physicist like me, didn't know either. But the older son, who has electronics as a hobby, said, "Of course I know. It's the most important transistor invented since MOSFET and BJT." So here we have a technology that has a really big positive impact, yet only the experts know about it. The IGBT is used as a switch or controller of electricity in basically any electrical appliance that uses more power than the computer. For instance, fridge or motors of electric vehicles, windmills, and so on. And in all these applications, it leads to savings of tens of percentages. So therefore, its negative carbon footprint is enormous. It is the mission of the Millennium Technology Prize to bring to people's attention this kind of hidden or embedded technologies which have absolutely great life-improving impact. Now, the world is facing the colossal challenge of climate change. That will not be solved by one magic thing. There are some promising ideas like AI and quantum technology, but their net negative carbon footprint is yet to be proven. The Millennium Technology Prize wants to remind young people who are searching for their walk of life, and also decision makers, about the fact that mitigating climate change requires a broad range of research. Fundamental science, but also company R&D. Fashionable and non-fashionable research. Hype and non-hype. Often, the world-changing innovations come from not something completely new, but from doing something old better, much better. This was the case with James Watt's steam engine. It was not the first one, but it doubled the efficiency. Now, this year, we saw global heat records again. At the same time, war, conflict, rise of autocracy require increasing attention from us. So is it even realistic to dream that humans can solve the climate change problem? Well, I believe so, because according to my life experience, in the end, people do what they need to do. They just do it in the last minute. So in this sense, it's crucial that some people are early. The IGBT technology was developed already in the 1980s, and now it has become crucial to our very survival. My warmest congratulations to Professor Baliga for his pioneering and world-changing innovation.
Wonderful. Thank you, Professor Terma. Next, we will see a presentation video on the mentioned insulated gate bipolar transistor, IGBT for short. This video will shed some light on what IGBT is and how it has managed to revolutionize global electrification. Let's have a look.
The world is increasingly dependent on electricity for our daily lives, and my technology, it delivers that electricity with greater efficiency than we could do before. So the IGBT is an electronic switch. It is like the switch on your wall for turning on and off lights, but the IGBT is able to do it at 100,000 times per second, and thus has allowed precise digital control of power, which was not possible before the IGBT, and that has revolutionized the way power delivery has been achieved. So today the IGBT is used in a very large number of applications in all sectors of the economy. When you go to a hospital, when you use this X-ray machine or the MRI machine, the CT scanner, they're all powered by using IGBTs. My favorite application for the IGBT in the medical area is the portable defibrillator. This would not have been possible without the IGBT. According to the American Medical Association, it is saving 100,000 lives per year just in the US alone. So the IGBT is going to have a lot of importance for future reduction of carbon dioxide emissions. For example, in the case of solar cells, it produces a DC voltage, and that has to be converted to 60 hertz stable AC power for delivery to homes and factories, and that's done using IGBTs. Same way, in the case of wind power, we get variable frequency output from the wind turbines. So we have to convert that using IGBTs to stable 60 hertz power that you can deliver into the grid.
IGBT stands for Insulated Gate Bipolar Transistor. The breakthrough with the IGBT was how it combines a fast-acting switch or control current, the MOSFET, with a powerful working current in the bipolar transistor. What makes this design unique is how electrons are redirected deep into the device. This redirection is crucial because it activates the vertical bipolar transistor, allowing a large flow of positive charges. By efficiently controlling and managing power in this way, the IGBT reduces energy loss, generates less heat, and supports high-power applications with greater reliability.
In our homes, the IGBT is used in your refrigerator, your air conditioner, your flat-top cooktop, your washing machine, your dishwasher, and 20 billion CFLs have been produced and used in the world since 1990 because of the IGBT. It's used in electric trains. So if we are successful in implementing all renewable energy sources and replacing fossil fuels, that is coal and natural gas, we should be able to save about 19 trillion pounds of carbon dioxide emissions each year. Another big application for the IGBT is in electric cars. All the manufacturers have been using IGBTs for the hybrid electric cars as well as electric cars. So if we replace all the gasoline-powered cars with electric vehicles, we should be able to reduce carbon emissions by 12 trillion pounds per year. So I think the IGBT has a long future of helping the planet. So my most recent innovation is a new device I call the bidirectional field effect transistor, or BIDFET. So this is a wafer that we fabricated with the BIDFETs, and some of these chips have been removed and put into these packages. And my power electronics colleagues tell me that this will revolutionize power electronics once again, like the IGBT did 40 years ago.
Jay's invention has already had significant impact on society, and we at NC State know this. The folks at GE know the impact of his IGBT device, but folks around the world may not know. And so I wanted to make sure that we nominated him for this prize so that people can understand from all over the planet what the impact of this device is on reducing our electrical energy consumption as well as saving our environment by reducing the CO2 emissions.
What an incredible innovation. The President of the Republic of Finland is the patron of the Millennium Technology Prize. And now we have a special message from the President of the Republic of Finland, Alexander Stubb.
Your Excellencies, ladies and gentlemen, it's a great pleasure as the patron of the Millennium Technology Prize to send you my greetings to this celebration making 20 years of the prize. In an age where technology and innovation holds the key to our future, the Finnish Millennium Technology Prize stands as a beacon of progress. It celebrates the greatest minds of our time. Those whose breakthroughs are not only reshaping industries, but also improving the lives of billions across the globe. The advancements recognized by this award, from clean energy solutions to revolutionary medical technologies, are directly contributing to the well-being of humanity and the preservation of our planet. I want to congratulate you, Professor Baliga, for your innovation, the IGBT, insulated gate bipolar transistor, which has been a significant element in limiting carbon emissions since the 1980s. The fact that indicates significance of the innovation, IGBT, has cut global CO2 emissions up to a 3 years amount. And an application that gives perspective is that all wind and solar energy plants all around the world are more effective when using innovative IGBT technology. It's no wonder that you, Professor Baliga, have been called the person with the world's largest negative carbon footprint. You are a true pioneer of sustainable development. Thanks to your valuable work, our planet is a better place to live. I wish you and your loved ones all the best for the future. And I now ask the winner of the 2022 Millennium Technology Prize, Professor Martin Green, and the winner of the 2024 Millennium Technology Prize, Professor Baliga, on stage. Professor Green, please present the trophy to Professor Baliga on my behalf. And once again, congratulations.
So honored guests and members of the selection committee, I'm very pleased to be here this evening to receive this prize. It is exciting to be celebrated as the 2024 Millennium Technology Prize recipient. This award is timely because it comes at the culmination of my 5-decade career working on power devices. So this prize serves as a wonderful capstone to my contributions. I humbly accept this great honor that puts me among the company of the other distinguished winners. It is, of course, delightful to receive the award today from Dr. Martin Green because of our long acquaintance through the IEEE Electron Devices Society. So my entire professional career can be summarized as the quest to create the ideal power transistor for power electronic applications. Now, of course, you can never invent or discover something that is perfect. You can only strive to come as close as possible to the ideal. So in order to achieve this, I have created many beautiful ideas over the years, which are described in over 100 US patents. My most impactful idea is the insulated gate bipolar transistor, IGBT, that you already heard a little bit about and has been highlighted in the award today. I'm very pleased that this device that I invented in 1979 has provided tremendous benefits to society. Consumers use this device for air conditioning and refrigeration in the home, for running washing machines and dishwashers, for cooking food using induction ovens, and many small appliances such as mixers, food processors, and rice cookers. In industry, it has become indispensable for operating robots in factories and for controlling motors. For transportation, it has allowed creating the electronic ignition system for gasoline-powered automobiles with greater efficiency. And as you already heard, hybrid electric and all electric cars would not be possible without using the IGBT to power the motors. And you already also heard about the medical applications that I'm very proud about. So the IGBT is designed to operate at high currents and voltages which serve these applications. However, there are many other applications such as your laptops, your desktops, and servers that require power transistors operating at lower voltages and power levels. The emergence of AI is expected to rapidly expand the data storage and server market, and as you heard if you were here this morning, greatly consume more energy. So my split-gate power MOSFET invention, which was based on a unique charge coupling physics that I proposed in 1996, has now become the dominant technology for these applications. Now, in order to come even closer to the ideal switch that I created a theoretical relationship in 1979 that is now commonly called Baliga's figure of merit. It predicted 1,000-fold enhancement in performance by replacing silicon with wide bandgap semiconductors. These are silicon carbide and gallium nitride. So during the 1990s, I had to invent unique structures, the JBS rectifier and the shielded channel MOSFET, to solve critical roadblocks to making this technology practical. And this resulted in the commercialization of silicon carbide rectifiers in 2005 by the industry and power MOSFETs in 2010. Currently, huge investments are now underway across the world to manufacture these devices as the next quantum leap in performance. So it is wonderful to see my vision coming true after 40 years, a long time. So looking into the future, the IGBT is an essential component in all renewable energy generation. As you heard in my video, it is utilized to convert the DC electrical power produced by solar cells and the variable frequency AC power produced by wind turbines into a stable 50 or 60 hertz power that is delivered into our homes and factories by the utilities. So the IGBT and other power transistors are an embedded technology which is not visible to the end users. They quietly improve the quality of life for billions of people around the world while mitigating environmental impact with more efficient delivery of energy. So today, the Millennium Technology Prize puts a well-deserved spotlight on these impactful innovations. I'm very grateful that my innovation is now among the dozen most impactful technologies created during the last 50 years. So thank you for this tremendous recognition.
What a spectacular winner. Congratulations once again. To close the award ceremony and the live stream, we will next hear from Rajaton. Rajaton is Finland's internationally most successful a cappella band. Already at this stage, I'd like to thank all of you who have been joining us online. Thank you so much for joining us. Rajaton, please.